All right, well, hi guys. Back with another video. I think it's the next lesson we're going to have to do. And as promised, this one's going to talk about how to factor all kinds of trinomials, even trinomials that don't have a leading coefficient of 1. And really, all we have to do is modify our process just a little bit, and we can get this factored relatively quickly. So again, if this was class, I have you guys start with this expression here in the box and try to factor it. We're not going to go there right now. I'm going to actually, on this video, I'm going to actually show you the process first. And then I might come back up to this box or the next one and show you how to factor it, okay? So let's go ahead and scroll down here to page 14, okay? And if you notice here at the very beginning, I have that sentence again that we had 2 videos ago. And I'm just going to have to modify that sentence just a little bit. So if we can go ahead and write this in here, I'm actually going to write it in black because I have this highlighted here. So here's what we're going to have to do. We're going to say, remember before, it was, the a wasn't there. It was just x squared plus bx plus or minus bx plus or minus c. And now the a is there, so that modifies our process just a little bit. So instead of us saying find a factor pair of c that adds to b, we need to write find a factor pair of a times c that adds to b. Okay, so that's how this is going to change the process just a little bit here. So I want you to see the method in full screen, and I'm going to explain it here a little bit. And then, if you notice, it's going to incorporate a lot of things we've already talked about here, okay? So the first thing we do is determine a, b, and c. We multiply a and c together, okay? And then we find the factor pair of ac that adds to b. We rewrite the b term as 2 terms, and I'll talk about how we split that up, okay? And we're going to use the coefficients in the factor pair to make this happen, so then it adds up correctly and those kinds of things. And then, as it turns out, what's going to happen here is by splitting that middle term, we're going to have 4 terms. And if you remember correctly, we have a process from the last video, I believe, on how to factor 4 terms, and that's factoring by grouping. So we're going to take the technique from the last video, and that's going to be our final step in this process. Okay, after we find a, b, and c, multiply them together, and find the factor pair, and then we write the middle term as 2 terms. Okay, so here's what we're going to do. I'm going to go ahead and do example 1 first, down here, and then we'll go back up and apply this to at least one of the rectangles up at the top. I'll leave the other one for you to practice with, and then I'll do at least a couple of the examples down here underneath here to finish up the video, okay? So let's go ahead and list our terms. So here's what we know. We know that a is the leading coefficient, so a is the number always in front of x squared, so a is 10. B is 1 this time because there's not a 1 there, in front, no number in front of the x, so a is 1. So, or b is 1, I'm sorry. And then c is -9. So let's go ahead and write these out over here. So we have a is 10, b is 1, and c is -9. So that is step 1 of the process up there. Okay, we're going to process to determine a, b, and c. Okay, so now it says multiply a and c together. So that's what we need to do now, is multiply a and c together. So we'll do that down here underneath the problem number 1. So a times c is 10 times -9, which is -90. Okay, so now instead of finding factor pairs of just c that add to b, we've got to find factor pairs of this product that add to b. Okay, so we're going to find a factor pair of -90 that adds to +1. All right, and you're not going to have to look very hard because it's actually already on the screen. Let me explain what I mean here by that. We'll have, you could do 1 and 90, and then you could do 2 and 45, and 3 and 30, and so on and so on and so on. But eventually, you would get to the factor pair, and of course, one of these has to be negative, so we'll do negative 90 and negative 45 and negative 30. Eventually, you get to the factor pair 9 and negative 10. And if you multiply those together, or add those together, you get negative 1 when you add them together. So you know that that's not the right factor pair because it has to equal positive 1. So all you have to do then is reverse the signs, and that is going to be the factor pair. Okay, so this is the factor pair that we need right here for our problem. Okay, so here's what I'm going to do. I'm going to rewrite the initial expression down here. Okay, and I'll mark this over here with 3 because we just did step 3. So now we're going to rewrite the expression. So we have 10x squared plus x minus 9. And now what we're going to do is we're going to split this middle term, and we're going to use each number from the factor pair. So what I'm going to do is I'm going to rewrite this as 10x squared plus 10x, I'm going to have to scoot this over just a little bit, there we go, minus 9x minus 9. Okay, so that's step 4 of the process right here. Okay, and then all we have to do is take that 4-term expression and factor it by grouping, like so. Okay, and you guys should have had plenty of practice on this by now, so this should not be anything new. And if you notice, the GCF of the first group is 10x, and I'm left with x plus 1. And I need to change the signs so they match. So I'm going to pull out a negative 9, and I'll be left with x plus 1. And then, for the final factorization, I will have 10x, and then I will have minus 9, and our groups match, which is great. Okay, so then in the other group, I just stick in there x plus 1, and that is the final factorization. So the final factorization is 10x minus 9 times x plus 1. You multiply that back out, using the FOIL method, you will get the original expression. Okay? So that's how we factor all trinomials. This method works for all of them. It's a surefire way. It doesn't require any guesswork. You could guess and check the factors if you really wanted to, but that's going to require you a lot of extra effort now because I have to find factors of both A and both C, a combination that works, okay? And that's going to take you a lot of time usually to figure out. This way, it does seem a little time consuming, but it's 100% guaranteed if you follow the rules, and you don't have to worry about guessing on anything. So I highly recommend going this route instead of just guessing and getting lucky. So you can make that choice as long as you show the correct work. You can make that choice as long as you follow all protocols and that kind of thing. Let's go back up here to the box, the first box problem, up here, the first rectangle problem. And we'll factor this one real quick. I'll show you how to do the method again. So we'll do 5x squared plus 12x plus 4. Okay. Over here, we'll say a equals 5 and b equals 12 and c equals 4. Okay. And so a times c equals 5 times 4 equals 20. That was step number 2. There's step number 1. Over here, step number 3. We're going to figure out the factor pair of 20 that adds to 12. And if you do all the work, you'll figure out that the factor pair we need is 10 and 2. Okay? So that's the factor pair we use to split up 12x. So we're going to split it up using 10 and 2. So we're going to write, this is step 4, by the way. So we're going to write 5x squared, and then use the factor pair, plus 10x plus 2x plus 4. And then we group them together. Okay? So the GCF of group number 1 is 5x, so I'm going to have 5x on the outside, and then I will have left over x plus 2. And in the second group, the GCF is positive 2. Left over will be, again, x plus 2. Okay? And the groups match. And so the final factorization would be 5x plus 2 times x plus 2. Okay? So this is the square or the rectangle on page 12 of the notes. If you notice 12 out of 23 here. And then I'm going to leave you this one to do on your own. It works exactly the same way as the one we just did above. Just plug in different numbers. Okay? Find your factor pair of a times c that adds to b. And you're off to the races and you can get this figured out. All right? I want to go back to the examples now. And look at example 1. We already did that one. I'm going to leave you example 2 to do. Okay? But I'm going to look at example 3 here for just a minute. I want to move over this one here. So let's go ahead and list everything out. Okay? In fact, here's what I'm going to do. I'm actually going to rewrite it as a trinomial first. Okay? This is the difference of two squares. We've seen that factoring pattern, or we've seen that expression before when we were talking about multiplying. Okay? Basically, the middle term has a coefficient of 0. So what I'm going to do is I'm going to rewrite it with a 0. So I'm going to have 25x squared plus 0x minus 49. So I just have a placeholder for the 0x there so that I can split it when I go to factor it. Okay? Now, let's pull up the calculator here. Just a second here. Let me find the calculator. There we go. And I'm going to pull it down and bring up Notability again and split the screen. So I have both of them here. Okay? And I'm going to turn this so we have a bigger picture. And I can script this over here some. All right. So the reason why I'm doing this is you guys have probably figured out 25 times 49 is a pretty large number. So we're going to have A is 25. B is 0, and C is negative 49. So A times C is 25 times negative 49. And this is really the only downfall we have to problems like this, is that there's just okay? There's just large numbers sometimes. So we have to find a factor pair of negative 1225 that will give me the correct sum of 0 here. So this is negative 1225. Let's write that a little bit better. Okay. So I'm going to cut to the chase a little bit here to save us some time on the video. If you concentrate hard enough, you'll eventually find out that I believe 1225 divides 35 evenly, and it's 35. Okay? So if you have 35 and negative 35, those add to 0, multiply to negative 1225, not 32, 35. So that's the factor pair I need. Okay, so I'm going to split the middle term. Whoops, let's write this correctly. 25 in red color, 25x squared plus 35x. And it doesn't matter which order you use the factor pair, it'll work out fine regardless. Okay, you might have to do a little negative factor GCF in the next step on a group, but it'll still work out. Minus 35x minus 49. We'll ungroup them there, and then we'll factor out GCF. So the GCF of the first group is 5x, and if we subtract that or multiply that out, we'll left with 5x plus 7. And the second group, the GCF, we'll have to pull out a negative sign because the groups don't match yet. So we'll pull out a negative 7, and left over we'll have 5x plus 7. And the groups match. So now all I have to do to finish this one up is write 5x minus 7 times 5x plus 7. And that is the final answer. A difference of two squares. Remember, a minus b times a plus b. Okay. There is a factoring pattern for this. We have certain patterns for these special cases. I'm going to show it to you. It's right here underneath problem number 3. Here it is. Okay. If you realize it's a factoring pattern, basically what you can do is take square roots of your two terms. Okay. Square root of 25x squared is 5x. Square root of 49 is 7. And then have one group where they're added together and have one group where the square roots are subtracted. And that's your factoring pattern. You do not have to know the factoring pattern. I'm not going to test you on that. I'm just going to test you on if you can just factor an expression. So you can do the ABC method on this just fine, okay? And you will not be penalized for going that direction. If you figure out the factoring pattern though for it, great. You can use that as well. But you're not required to know how to do that, okay? Let's continue on to example 4. This is a perfect square trinomial, okay? So again, you can also, it has a factoring pattern, and I'll show you those here in just a minute. But if you don't know it, that's okay. You can still factor it using the ABC method, which how I'm going to show you how to factor it anyway. So let's get our ABC. So A is 4. Oops. B is 4. And C is 1. Okay? So when I multiply A and C together, I get 4 times 1, which is 4. So I need a factor pair of 4 that adds to 4. Well, there's not very many factor pairs of 4. So I can try 1 and 4, or I can do 2 and 2. And 2 and 2 is the one that I want. I want them both positive because my sum is positive and my product is positive. Okay? So now all I'm going to do is split it and group it. Okay? So I'm going to split the middle term, and then I'm going to group them together. So I have 4x squared, and then I'll have plus 2x, plus 2x again, plus 1. Group them together, like so. GCF of group number 1 is a 2x, and then I have 2x plus 1 left over. And like the previous video, we have a GCF of 1 in group number 2. So I gotta make sure I put that on the outside, so I have two binomials. And then leave it as 2x plus 1 on the inside, so then the groups match. And then the final answer on this one is 2x plus 1 times 2x plus 1. Now, you guys should remember this from the previous topic, that I can also write that as 2x plus 1 quantity squared, because that kind of got some of you guys in trouble when you tried to multiply it back out. Just FYI. So that is the final answer. This is a perfect square trinomial. It has a factoring pattern. Let me put that square back. It has a factoring pattern. You don't have to know it again. It's different on whether or not the sign with the middle term is positive or negative. Okay, that's the only difference. Okay, if it's positive all the way through. If it's negative all the way through. You don't have to know this again. Okay. It's just what if you want to keep it in mind for when you see it on an assessment. Should it be on an assessment, then you know it's a possibility, okay? That's all. I'm going to leave you with examples 2 and 5 to work, and also that one at the top on the rectangle for some extra practice. Be careful for GCFs. Watch for GCFs. Hint, hint on number 5. Find a GCF first before you continue your factoring pattern. And I'm going to leave it here on this one. We have one more video to do, and then we're done with our factoring unit. All right?